All right, for section 2.4, we are talking about vertical angles. We will also be looking at linear pairs. Our objective is to find the measure of angles formed by intersecting lines. Okay, which you will soon find out some of those angles are called vertical angles. Can anybody raise their hand and tell me what they got for number 1 on the warm-ups? John? 0. If you're multiplying by 0 at any point, the whole thing equals 0. On the second one, we're not really finding a value, we're just simplifying because we don't know what x equals. Same thing down here, we don't know what u equals. So we're just going to simplify, this time by distributing. Somebody new, tell me what you got on number 2. Well, I've heard from you, so I'd prefer to hear from somebody new first.
I'm new.
Yes, that's very clever. So you're on the right track. We distribute that -5. That would give us -5x. And then you could keep it as a subtraction problem, minus, but this would then be a -40. So usually we would rewrite it as -5x plus 40. So we just had to distribute the -5. For number 3, I'll go through that one rather quickly. We have to distribute both the 3 and the -8, and then we will combine like terms. So we have -3u minus 15 minus 16u minus 8. We have to be careful with our signs when we distribute. Then we can combine like terms. The u's can be combined. They have the same variable with the same exponent. So that is -19u. -15 minus 8. Those are both constants, so they can be combined. -23. For vertical angles, those are two angles that are not adjacent, whose sides are formed by two intersecting lines. So two intersecting lines, two angles that are not adjacent. So if I label these angles, I'll just label them 1, 2, 3, and 4. Which angle is not adjacent to angle 1? Connor? 3. Okay, I could trace angle 1 and angle 3 without tracing the same ray twice. Okay, so angle 1 is vertical to angle 3. So we would angle 1 and angle 3 are vertical angles. But that's not the only pair of vertical angles there. What's the other pair? 2 and 4. So angle 2 and angle 4 are also vertical angles. Okay, we have two straight lines intersecting. We look for the angles that are not adjacent. All right, for a linear pair, that hopefully is pretty self-explanatory. We have a pair, meaning there are two. Linear means they're on the same line. Okay, so we know we have to have a line, and somehow it is split into two angles. So this ray that I'm about to draw to split it could go in any direction, really. I'll make it go here. again, I could label these 5 and 6. So angle 5 and angle 6 are a linear pair. Now up here on our vertical angle diagram, we also have linear pairs, right? 1 and 2 make a straight line. So up here, 1 and 2 are still a linear pair, even though it's in a vertical angles looking diagram. So we don't have to have the line stop here. This line at the bottom by angles 5 and 6 could keep going and cut all the way through. It would still make those a linear pair. They still make up a straight line. Remember, postulates are accepted without a real proof or a reason why, but this postulate should make sense to us. If two angles form a linear pair, then they are supplementary. So two angles form a linear pair, then they are supplementary. If you want, you can draw another little picture off to the side to help this make sense. We've done this already. If we were to add up these two angles, we could call them 5 and 6 again like we did last time. We knew before today that the measure of angle 5 plus the measure of angle 6 equals 180 degrees because we talked about straight angles having a measure of 180 degrees. So this postulate really is not anything new. It's just a more formal way to state it. This theorem is super short, sweet, simple, easy to remember. Vertical angles are congruent. It is a theorem because we can prove it, and we might work on doing that later this chapter. We won't worry about it today. But when we see vertical angles, again, we could do a diagram similar to what we did earlier. Okay, in this diagram, we already talked about how 1 and 3 are vertical angles because they are formed by two intersecting lines and they are not adjacent. But this theorem tells us that we know angle 1 is congruent to angle 3. In other words, the measure of angle 1 is equal to the measure of angle 3. They have to have the same degree measure. In these examples, we are asked to determine whether the angles are vertical, a linear pair, or neither. So make sure you copy down these diagrams. Again, they don't have to be perfect. They should be similar to the ones we see here and also labeled the same way. All right, on that first one on the left, Keon, do you think they are vertical, a linear pair, or neither? 1 and 2. Vertical. We've got two intersecting lines. They are not adjacent, so they are vertical. On letter B, the one in the middle there, Connor, what do you think about angles 3 and 4?
Linear pair.
Wonderful. They form a straight line, so they are a linear pair. Finally, on part C, Kara, what do you think? Neither. Very good. Okay, they're definitely not vertical because they are adjacent to each other. So they can't be vertical. If we are only focusing on those two angles, they do not make a straight line. Okay, so they're just some adjacent angles, nothing very special about them. All right, so we rewrote these bigger. They're not extra, they're just bigger writings of what's down in those angle measures. If I were to look at these angles, how would I identify them? Vertical or linear pair? They're a linear pair. They are a linear pair, and our postulate from earlier said that they must then be supplementary, meaning they add to 180 degrees. So if I add these two angles together, x plus 4 plus 3x minus 4, I should get 180. Okay, we have to link together a lot of pieces to be able to set that up. We have to recognize it's a linear pair, know that linear pairs are supplementary, know that supplementary means they add to 180. It's a lot to remember. But then from here, it's just algebra. Combining like terms means that I have 4x. The positive 4 and the negative 4 cancel to 0, so they're just gone. Equals 180. The only thing I have to do from there is divide. If I divide 180 by 4, I get x equals 45. Well, x won't have a degree measure on it. Okay, so x equals 45. And before, when we did these types of problems, we were done. But did they ask us to find x? No, they asked us what the measure of angle CDF is. Angle CDF is the bigger one over here. How are we going to figure that out? Plug 45 in. So I'm going to take this away so that I've got some room to work. So I'll just kind of separate that. So I found x. Now I'm going to plug it in. 3 times 45 minus 4. I plugged it in down here to this x. 3 times 45 is 135. Subtract 4, we get 131 degrees. So that is the measure of angle CDF. 131 degrees. Probably the longest part of this problem is copying it down. Once we get it copied down and we identify angle HJK, we know that that angle's up here. So you can mark it if it's like, okay, this is the angle I'm interested in. What is that angle's relationship with the one that we have labeled as 88 degrees? They're vertical. And if they're vertical, that means that they are congruent. And if they're congruent, that means that their measures are the same. Okay, so see, this is the thought process we have to go through. So that means angle HJK measures 88 degrees. Not a hard problem to do, however, it involves a lot of knowledge. Alright, so because angle 1 is vertical to the angle we knew, it has to be the same. So those are both 108. Okay, do you want to tell me 2 or 3?
2.
2, okay. What's angle 2?
Would be 54.
I think it would be a little more than that. So remember, the angle 2 is going to be supplementary with this angle that we know. So I think to find angle 2, we need to do 180 minus 108. What would that give us?
72.
72. Wonderful. Okay, so angle 2 is 72 degrees. So that means Cade had to do all the hard work. Wow, none of these people are here. Julian! Now that Cade did the hard work, can you tell us what angle 3 is? It's also 72 degrees because 2 and 3 are vertical to each other. Or, if you wanted to do the work all over again, you could say, well, 1 and 3 have to be supplementary. So let's do the whole process again on B. Angel A, pick an angle and tell me what its degree measure is. Wonderful. The measure of angle 3 would be 91 degrees because angle 3 is vertical to the one that was already marked. He's here. Mariah. Which one do you want to do? Angle 1 or angle 2? Which one? 1? Okay. So, if we look at angle 1, it makes a linear pair with angle 3. So 1 and 3 would have to be supplementary. So that means I could take 180 minus this 91, and that should give me the degree measure for angle 1. What? 89, good. So when we subtract those, we end up with 89 degrees for angle 1. All right, now that we know angle 1, IKEA, what's angle 3? Also 89 degrees. Wonderful. All right, let's work on example 5A first. The first thing I need to know before I can even start setting up any sort of algebraic equations is what the relationship between those two angles is. John, what is the relationship between them? They're vertical. Good. So I have to recognize that those are vertical angles. After I recognize that, then I start thinking about what that means. Vertical angles are congruent. Congruent means they have the same measure. That means they're equal. That's the important part here. I can set these equal to each other. 3x minus 5 equals 6x minus 56. We have to identify the relationship so that we know what kind of problem to set up. The rest is just algebra. All we're doing is finding x. You can set it up however you want. My personal preference is going to be to subtract 3x from both sides and add 56 to both sides. That leaves me with 51 equals 3x. When I divide, what do I get? 17. I don't anticipate these problems being challenging. That's not what they're meant to do. They are meant for you to be able to recognize relationships and understand what those relationships mean. The algebra is something that I think that you should already have a handle on before getting here. If it is a struggle, let me know. We can work on it, go to tutoring, whatever we need to do to get back on track. Okay, for 5B, again, before I start doing anything with my expressions, I want to know the relationship I'm looking at. Quentin, what's the relationship between those angles? Here and here.
I don't know.
Our options are vertical or linear pair, so you got a 50-50 shot.
Vertical.
Man, went with the wrong one. Brandon, what are they? Linear pair because they form a straight line. Okay, if the two angles put together form a straight line, they are a linear pair. Linear pairs are supplementary, which means that they add up to 180. So that's the relationship I needed to identify. Because they're a linear pair, they're supplementary, I can add them together and set them equal to 180. X plus 10 plus 5x plus 10 equals 180. Different from the last problem. Every year that I do this, I see students fixate on setting things equal to each other as soon as we learn vertical angles, and then that's all they do. Don't set these equal to each other. It's not going to work. I mean, you can solve it, but it won't give you the right answer. So here we start combining like terms. 6x plus 20 equals 180. We start to solve by subtracting 20. 6x equals 160. We divide by 6. So what do we get for x? It's not going to come out to a whole number. That's okay. What do we get? 26.6 repeating. Okay, so we'll put that down there. Normally I like it when they come out nice, but they don't have to.